The diagram shows r is equal to 1 plus cos theta. Find the shaded area in the cardioid. So this shape here is called a cardioid, and you get it from this polar equation. R is equal to 1 plus cos theta. Okay, so if we draw the diagram, to find the area, we need to do the integral from alpha to beta to a half r squared d theta. Well, it's okay, we've got r, but we haven't got alpha and beta. But this curve starts when alpha is equal to 0, and it goes all the way around here, and when beta is equal to pi. So we can set up our integral. It's important that you set up the integral properly. So the area will be a half. Now you can take the r half out of the integral sign. Might make life a bit easier for you. The integral from 0 to pi, because we're doing from 0 to pi, of r squared. So that's going to be 1 plus cos theta all squared d theta. Right, before we integrate, we must prepare the integral properly. So it's going to be a half. So if we expand this, it will be 1 plus 2 cos theta plus cos squared theta d theta. By now you should know how to expand a plus b all squared. Right, in order to do the integral of cos squared theta, we need to do a substitution of a trig variable. So we know that cos 2a is 2 cos squared a minus 1. Therefore, cos a is equal to a half of 1 plus cos 2a. This is the standard result. So substituting in, we get a half from the integral from 0 to pi of 1 plus 2 cos theta, replacing cos squared with a half plus a half cos 2 theta d theta. And then just before we integrate, we'll just do 1 plus a half. So that's going to give me the integral of 3 over 2 plus 2 cos theta plus a half cos 2 theta d theta. So notice I've prepared the integral before actually integrating it. Right, now integrating, don't forget the half at the front. 3 over 2 becomes 3 over 2 theta, 3 theta over 2. If you integrate cos, you get sine, so it becomes 2 sine theta. Cos 2 theta comes from sine 2 theta. If you differentiate this back, you're going to get a 2 in the front, but we want a half, so we're going to have to put a quarter. If you think, differentiate back 2 over 4 will make a half. Now the limits now go here 0 to pi, so pay attention to the correct notation. Substituting in these values, we're going to get a half times 3 pi over 2 plus 2 sine pi plus a quarter sine pi, and then when we put 0 in here, you need to check carefully. We'll get 0 from here, we'll get 0 from here, we'll get 0 from here, but don't always assume that. And it also happens that the sine of pi, sine of 180, is also equal to 0. Same here, sine of 180 is 360 is also equal to 0. So this becomes a 3 pi over 4 square units. Okay, so this has been a video to show how to integrate a polar curve. I hope you've understood, and I thank you very much for watching.